In the previous presentation, we talked about how data mining can be a very crucial technique to reap benefits of the ever-growing amount of data we are generating. So in this journey of demystifying data mining, the first piece of puzzle we will look at is how do we represent our input into the various learning schemes. In this presentation, we will also give a very brief view of different learning schemes that we have, and towards the end we will look at a standard file format to represent our input. So let's begin. One of the most crucial things that we need to figure out before we move to input representation is what do we want to learn or achieve by applying these various data mining techniques. This is what we call a concept. A concept should be intelligible so that it can be well understood, and it should be operational so that it can be applied to actual examples. Moving ahead to actual data representation, kindly check the table below. In this table we have two attributes, that is name and age, which are plotted against two instances or the horizontal rows. This is how we generally represent our input. Moving ahead to different types of learning. The first learning technique that we will look at is classification learning. In classification learning, the learning scheme is presented with a set of classified examples from which it is expected to learn a way of classifying unseen examples, that is, to predict a value of a particular attribute. This type of learning is also called supervised learning. For example, let's check this table. In this table, we are using the attribute outlook, temperature, humidity, and wind to predict the attribute play. The attribute which needs to be predicted is also called a class. By using this table, we have derived the following three classification rules. This is how classification learning takes place. Then we have numerical prediction. Numeric prediction is same as classification learning, but here the outcome or the class of the example is basically a numerical value. This type of learning is also called regression. The next type of learning we have is clustering. In clustering, groups of examples that belong together are sort and clubbed together in a cluster. That is, we basically divide the whole input set into a set of clusters, as you can see in the figure given below. Clustering is an example of unsupervised learning. Moving ahead, the next type of learning we have is association. In association, any association among features is sought, not just the one that predict a particular class value. Therefore, here we can predict any attribute and not just a class. It can also predict more than one attribute at a time. For example, in the table given below, we have find out that there is a strong association which says that whenever milk and bread are bought, customer also buys butter. Moving ahead, some of the few important terms. The output produced by a learning scheme is called a concept description. The table that we talked about in which we were plotting attributes against instances is what we call a flat file. Now, according to closed world assumption, we only specify the positive example in a flat file and rest example are assumed to be negative. This is what we call a closed world assumption. We will be looking at an example of closed world assumption as we move ahead. Now we will look at 4 steps of pre-processing which we need to perform on our data to make it suitable. The 4 steps are data assembly and aggregation, data integration, data cleaning, and general preparation. The first step, that is data assembly and aggregation. According to this, our instances which are there in the input should be independent. This independence can be achieved by a technique called denormalization. In the terms of a database, denormalization is nothing more than just joining of two or more relations to produce a single relation. Denormalization is possible with finite sets of finite relations. Now we will look at an example of denormalization. Suppose we have a classification scheme in which our input is a family tree as given below. From this, we are trying to find sister of relationship. Now each row of the tree can be mapped to instances to represent such a table. As you can see that we cannot make sense of this with respect to our requirement of finding sister of relationship. Therefore, we need to denormalize this table to get the table given below. Here, as you can see, we have joined two tables to get a single table. Each instance of this table is independent with respect to every other instance.